Hello and welcome to revision classes on television. Today, we will be having a session in mathematics, and our guide is Rafiat Yusuf. She will be reviewing past questions on indices from the 2015 to 2019 SSCE.
Question number 1, we have if 27 raised to power x times 3 raised to power 1 minus x all over 9 raised to power 2x equals 1. Find the value of x. Okay. Remember that when you are taught indices, we have some laws guiding these indices. We have the multiplication law, the division law, the power law, and so on and so forth. So we're going to be applying those laws in these questions. So before we can apply those laws, the first is that we have your question and the smallest base here is 3. You will try to make the other numbers to be in that base 3. So making the other numbers to be in base 3, we know 27 will give me 3 raised to power 3, not forgetting your x is still there, times 3 raised to power 1 minus x all over 9 raised to power 2. The 9 now, we are replacing it with base 3, which is 3 raised to power of 2. Not forgetting we have the 2x still there, equals 1. Now, we'll be applying one of the laws, which is the multiplication law, which says when 2 times are multiplying each other with the same base, the power, let's say we have power b and power x. If it is multiplication, you are going to add the powers. This will give me a, b plus x. Now, applying this here, you can see that this and this, they are the same base. So we want to apply the multiplication law. We have 3x plus 1 minus x all over 3. You can multiply your 2 because this bracket is multiplication. So 2 times 2x will give 4x, all equals to 1. From here now, we'll open up a bracket. Anytime you have a bracket, you treat your bracket first. So opening up the bracket, we have 3 raised to power 3x, 1 times plus times 1 is plus 1, then plus times minus you give minus x, all over 3 raised to power 4x, all equals to 1. So we continue from here. You can collect like terms. You know, the one that has x, you bring them together. Collecting like terms, we have 3 raised to power 3x, then you have minus x plus 1. This is 3 raised to power 4x, all equals to 1. You have to evaluate this. 3x minus 2x, you evaluate that. 3x minus 2x will give you, 3x minus x will give you 2x. So you have 2x plus 1, all over 3 raised to power 4x equals to 1. Now, this leads us to another law, which is the division law. The division law is when you have the same base, and I'm using the power b and power x. If it is division, you will subtract. Unlike the multiplication where we added, this you will be subtracting to give b minus x. So applying that law, in this case, we have 3 raised to power 2x plus 1. Remember that this base here now, it will be subtracted from here, minus 4x equals to 1. The next is you evaluate this by collecting like times as you did earlier. This will give me 3 raised to power 2x minus 4x plus 1 equals to 1. That's 2x minus 4x will give 3 raised to power 2x minus 4x will give you minus 2x. Then you still have plus 1, all equals to 1. Now, looking at this, they are not in the same base. We'll also try to make them to be in the same base so we can evaluate. How do we make this one to be in base 3? This leads us to another law, which is the power law, the zero law, where you have any number raised to power 0 will give you 1. So this one, we can represent it as 3 raised to power 0 is equals to 1. If I use this 3 raised to power 0 to replace my 1, I have not committed any crime. So you can just, instead of writing 1, you replace it with 3 raised to power 0 so as to be in the same base with this 3. So I have 3 raised to power minus 2x plus 1 equals 3 raised to power 0. You see, I've replaced this 3 raised to power 0 with this one. Now, we know that they are now in the same base. The next thing is, if they are in the same base, you equate their powers. Equating their power, you have minus 2x plus 1 equals 0. We can collect like times from here. This is minus 2x is equals, taking plus 1 to the other side, it becomes 0 minus 1. That's minus 2x equals minus 1. Remember, we are looking for the value of x. That means we have to divide both sides by the coefficient of x so that our x will be standing alone. We're dividing both sides by the coefficient of x, which is minus 2. This gives minus 2, we cancel minus 2 here. I have my x equals, the negative will also cancel negative. Minus divided by minus will give you plus, don't forget that. So now we no longer have negative again. Our final answer will be 1 over 2, which is half. That brings us to the end of this question. Question number 2. Simplify 3 raised to power n minus 1 times 27 raised to power n plus 1 all over 81 raised to power of n. Having in mind that anytime you are dealing with indices, there are some laws that you have to apply. That is why before you do anything, you must know all your laws in indices. So like we did in our previous question, you see, I said the first thing is you look at the base. If they are not in the same base, you try to simplify and make them to be in the same base. The simplest number we have here is 3. So we try to make the 27 and the 81 to also be in base 3. So doing that, we will replace, we have 3 raised to power n minus 1 times 27 is 3 raised to power of 3. But there is a power there already, which is n plus 1. Then 81 is 3 raised to power 4. That's 3 raised to power 4. There's a power there, which is n. I said if there's any bracket, you must always do the bracket first. So we have a bracket here. Let's open up the bracket. This will give 3 raised to power n minus 1 times 3 raised to power, opening the bracket here, I have 3 times n, 3n, plus 3 times 1, which is 3, all over 3 raised to power 4 times n here will be 4n. So from here, we can see that this leads us to one of the laws of indices, which is the multiplication law. We have done that before. We know multiplication law, once the 2 times are in the same number, you add their index. So adding their index, I have 3 raised to power n minus 1 plus 3n plus 3 all over 3 raised to power of 4n. Opening the bracket, 3n minus 1 plus times 3n is plus 3n, plus times plus 3 will still give you plus 3, all over 3 raised to power 4n. We have to simplify this before we move ahead. Simplifying means you collect like terms and simplify. So collecting like terms, n and 3n, bring them together, n plus 3n, n plus 3n, minus 1 plus 3, minus 1 plus 3, all over 3 raised to power of 4n. So we evaluate. 3n plus 3n will give 4n. Then minus 1 plus 3 will give plus 2. All over 3 raised to power of 4n. Now, we have evaluated our index. The next law this is leading us to is the division law, where, you know, when they are in the same base and they are dividing each other like that, you will subtract their index. So this gives 3 raised to power of 4n plus 2 minus 4n. You have something like this, you know, you collect like terms to simplify. So we have 3, 4n minus 4n plus 2. We have 4n to subtract 4n. That will give us 0. So now we no longer have any 4n there. What is left is the plus 2, which is 3 raised to power 2. And, you know, 3 raised to power 2 will give you what? We give 9. So our final answer is 9. We have simplified the indices. Question number 3. If 0.25 raised to power of y is equals to 32, find the value of y. I know students, they don't normally like decimal. Anytime they see decimal, they get scared. But anytime you have a decimal, what comes to your mind should be, let me try to simplify this decimal by converting it to fraction. So looking at this question, you can see a decimal there. The thing you should come to your mind should be, I need to simplify this by putting it in fraction. So putting this our 0.25 in fraction, you know it will give you 25 over 100. Don't forget you have a power there, all equals to 32. So 25 over 100, we can simplify. 25 can go in 100. 25 here 1, 25 in 100 is 4. This gives 1 over 4 raised to power of y equals 32. If you have a fraction like this, this 1 over 4 will be 4 raised to power of 1. This is the same thing as this. It's the same thing, you are just trying to rewrite it. So as to make it simpler, y raised to power of y equals to 32. We have a bracket, so try to open up your bracket. Indices, when a power is multiplying another power, you just multiply them. This will give me 4 minus 1 times this y. We have minus y equals 32. So we have this equation. You look at it. How can I simplify this? Let's try to make them to be in the same base. This is 4. Can we make 32 to be in base 4? If you look at it well, I don't think that is possible. But we can simplify 4 to be in base 2, simplify 32 to also be in base 2. So that means this 4 will also be simplified. So simplifying this 4, we know 2 raised to power 4, 2 raised to power 2 will give you 4. So this is 2 raised to power 2. Then I have minus y equals 32 is 2 raised to power of 5. You have a bracket there. You eliminate the bracket. 2 times minus y will give minus 2y equals 2 raised to power of 5. Now they are in the same base. If you have a base equals to another base that are the same, you just equate their index, you equate their powers. So this we go, I'm equating my powers, minus 2y equals 5. Remember, we are looking for the value of y. So you divide both sides by the coefficient of y, which is minus 2. Doing that, I have divide by minus 2, divide this by minus 2. Minus 2, we cancel minus 2. Finally, we have our y, which is what we are looking for. Then 2 into 5 can be simplified as 2. Don't forget your negative is there. 2 into 5 is 2, remainder 1 over 2. This gives us the value of y. Okay, we have our question here on the board. Before you can do anything, you look at the question well and see how can you apply, which of the laws can you apply to this question. The first thing, I would advise not to go ahead and cancel this 2 with this 8, because this 1 over 8 has an index. So you can't just bump and just go ahead to do that. So the first thing is you can decide to separate them. You know, if we have 2 times 1 over 8 all raised to the power of x. If you do this, if you simplify this, it gives this. So there's no crime separating them so as to simplify further. So do the solution now. Separating, I have 2 raised to the power of 1. 2 raised to the power of 1 is still 2. Times 1 over 8 raised to the power of x equals 32 raised to the power of x minus 1. We can simplify this 8 to be in a simpler base, which is base 2. So we have 2 raised to the power of 1 times 1 over 8 is 2 raised to the power of 3. 2 raised to the power 3. All raised to the power of x equals 32x minus 1. Remember in the other question we solved, where we have 1 over 4 to be 4 raised to the power of minus 1. Applying this in this case, you know, from this 1 over 2 raised to the power 3, it can give 2 raised to the power of minus 3. So here now we have 2 raised to the power of 1 times, this is now 2 raised to the power of minus 3. This is the same thing as this. Not forgetting we have an index x, which is equals to 32 raised to the power x minus 1. Now, we see that this part are all in the same base. Can we make this other 32 to also be in base 2? Doing that, we know 32 is, we have 2 raised to the power 1, 2 raised to the power minus 3 raised to the power of x equals 32 now will be 2 raised to the power of 5. But we have an index of x minus 1. That will be, put it in brackets so as not to miss your sign. So, putting that in bracket, I told you anytime you have a bracket, try to simplify your bracket before any other thing. Bracket first. So let's simplify our bracket. All the bracket we have, we want to remove them. So we have 2 raised to the power of 1 times the bracket here first, minus 3, we multiply the x, which will give minus 3x. So this is now 2 raised to the power minus 3x equals, now we have another bracket here, 5 times x. This is 2 raised to the power 5 times x will give 5x. Then 5 times minus 1 will give minus 5. That is why we put this in brackets. Don't forget, because if you do the mistake of just multiplying the 5 with x and you do not multiply with minus 1, your answer will not be correct. Remember that we have a law, multiplication law, which is when you have the same base, you will add their powers. So now here, this law will be applied. We have 2 raised to the power 1. This will be plus minus 3x equals 2 raised to the power 5x minus 5. Simplifying, we have 1. This plus minus will give minus 3x equals 2 raised to the power 5x minus 5. The next thing, you see the base is equals to the base and they are the same. you will equate your index, that means your powers. This we cancel. Equating our index, we give 1 minus 3x equals 5x minus 5. Simplifying further, you collect like terms. Bringing minus 3x to this side, minus 5 to the other side, we have 1 plus 5 equals 5x plus 3x. Sorry. So 1 plus 5 will give 6. 5x plus 3x will give 8x. Remember, we are looking for the value of x. That means we have to eliminate this coefficient of x, which is 8. How do we eliminate that? You divide both sides by 8 so that our x will be alone. Dividing both sides by 8, 8 we cancel 8 here. Finally, our x is alone as the subject. Simplifying this, 2 can go. 2 in 6 will give 3. 2 in 8 will give 4. So our final answer is 3/4. Question number 5. If 2 raised to the power of n is equals to y, find 2 raised to the power of 2 plus n over 3. So, this question, this is like a guide. This 2 raised to the power n equals to y is a guide. Like when you are solving this and you arrive at where you have 2 raised to the power n, you will substitute the value of y there. So that is just what you're asked to do. So doing this solution, looking at this 2 is having the power of this 2 and the power of this 2, n over 3. We can separate the index. That's 2 raised to the power of 2 times 2 raised to the power of n over 2. You know, n over 3. You know, this is the multiplication law we always apply. Where we have this having the same base, we add the powers. That is what I try to simplify here and try to separate them in their indices. So now we have 2 raised to the power 2, and the 2 is also having this index n over 3. You have, this can also still be separated so as to have this 2 raised to the power n alone. You can separate further. 2 raised to the power 2 will give you 4 times 2 raised to the power n times 1 over 3. This n has been separated with the 3. If you have n times 1 over 3, it will still give you n over 3. You see? You have not committed any mistake. We are just trying to simplify so that we have 2 raised to the power n alone. So that we'll be able to substitute the value of y instead of using 2 raised to the power n. So simply, now we have 2 raised to the power n. We have 4 times 2 raised to the power n is now what? Is now y. Then the power of 1 over 3 is still there. Finally, our answer will be 4 times y raised to the power of 1 over 3 will give 4y raised to the power 1 over 3.
That's the much we can take today on the program. Join us next time for another educating session.